Recording. All right. Good morning from Dallas, sunny Dallas, Texas. I have the honor of being here with Filip Makraduli. I hope I'm pronouncing that somewhat correctly. Filip, you'll correct me in a minute if I didn't. Filip works for SuperLinked and is heavily involved with AI and vector embeddings in specific. And I've done a couple of podcast shows about knowledge graphs, and vector embeddings are something that is similar and related to it. So I thought it'd be a great idea to interview you this morning and find out a little bit more about that particular technology and how it fits into the AI picture. So, Filip, if I may ask you, would you be so
Yeah.
kind to introduce yourself and tell us a bit more about you and SuperLinked, the company for which you work?
Yeah. So, hi, and thank you for having me. It's my pleasure to be here and talk about these things because I think, especially with the AI world moving so quickly, it's nice to kind of stop for a bit, and reflect how things have been. Um, and yeah, not a morning in London, but still a good afternoon. And yeah. It's so basically, yeah, my name is Philip. I work as an ML developer relations engineer at SuperLink. So basically that's my background is in ML engineering. So I've been an engineer and a data scientist. But in this role, I'm also working a bit kind of on the front-facing part of the business, the open source aspect of it, working with certain clients, speaking at events. So basically, a huge chunk of the work is communicating properly what the company is doing, what we like to kind of test out and get the results in our with our ML kind of initiatives. And yeah, basically, I work at SuperLinked, and this is a framework that kind of bets on the fact that the future of ML looks embedding native or vector native in a way. So, in order to kind of paint the picture properly, all of this, the AI world, especially with search, retrieval systems, recommendations, kind of the bar is higher for what users expect. So with ChatGPT and all the LLMs, at least for me as a user, but I'm sure for many of the listeners, when you go to a website that's even a basic shopping website, the way you kind of search for products now is more similar to what you would do to ChatGPT. Like you would write, oh, I want this kind of shirt above this price, but not in red. And I want it between this sizes, but I might want to try something that has this little thing on the sleeve, but no stripes. So the kind of the world of enterprise and kind of e-commerce and hospitality and so on, a lot of industries that have this natural search capability. Um, I think we're not ready for this quick transition of how users behave. So what Superlink does is it offers this framework where all of this search and recommendations use cases with complex queries like this, complex recommendations that integrate a lot of data from various sources. It basically enables to kind of solve these problems end to end, whether that's kind of just accurately retrieving these dresses that I mentioned, or ingesting the data, or kind of integrating multiple data sources. So yeah, it's kind of like a vector native solution for teams that do this, like AI teams and data scientists and so on.
Fascinating. I
Yeah.
actually wrote an article in my AI and Loc newsletter not too long ago, and I'm paraphrasing the title because I don't know it by heart anymore, but it says something like, when was the last time you did a Google search? Google search is more or less dead because, like you said, we're going to be describing and engaging in conversations with our search engines in the future much more rather than to look for keywords.
Exactly.
We have done a number of high profile podcasts and events on knowledge graphs in the localization industry recently. and we haven't done anything really on vector embedding. So maybe since my audience knows a thing or two about knowledge graphs already, we can contrast it a little bit.
Yeah.
Can you explain the difference between knowledge graphs and vector embeddings a
Yeah.
bit?
Yeah, I mean, those are kind of terms and like paradigms that are often encountered in the ML world. And
Yeah.
they're kind of related, but also different.
Okay.
They're related in the sense that in a lot of applications or use cases, you might find them both present in the solution, like both embeddings and then knowledge graphs at a later stage or an earlier stage and so on. But the main difference, I think, it boils down to kind of the interpretability of it. So with knowledge graphs, the key thing is kind of the relationships between the entities. So there is the nodes and the edges. And if we're talking about like Paris, for example, it would be linked to France or the Eiffel Tower. The idea is that you have the link between these entities. And it's kind of like a map that guides you through certain topics to kind of give you like a direction that's very specific. Like, okay, you go from Paris and you end up to the Eiffel Tower through different kind of paths within the graph. And with embeddings, the way they work is kind of a bit more complex in the sense that there is not a straightforward interpretable nature of understanding embeddings. Basically, embeddings represent data and they're vectors with a bunch of numbers in them that kind of represent a certain characteristic. So, for example, with this same example with Paris and the Eiffel Tower, when these two words are embedded, you would kind of get the vectors in a similar spot, like next to each other in this vector space. However, you wouldn't know kind of exactly why or how close they are, depending on the embedding model you use, depending on kind of the whole context of all the data that you have. So usually there is a model that embeds the data and generates this vector representations of the data, so-called embeddings. And the good thing is that within this vector embeddings, a lot of data is captured and a lot of relationships between these words, but a lot of these relationships are nuanced. So it can be some little fine details that you cannot kind of strictly say as you would in knowledge graphs, like, oh, Paris, France, literally I'm connecting them and you can see the path between. So this is also something that kind of at SuperLinked we're trying to solve, and we've seen success in to kind of be able to interpret embeddings and be able to kind of get more of an insight and control of what's encoded, what's represented within this vectors of numbers, and that kind of helps further down the line for businesses and so on to kind of have a better understanding of these nuances.
Yeah, of course, for
Yeah.
us this morning, for us, what we really want to know is the connection to localization and multilingual content and the role vector embeddings can play in understanding languages across borders, so to speak. So, how do you think vector embeddings help machines understand meaning across different languages?
Yeah, yeah. I think they're like a key concept and a key thing, especially nowadays with large language models. So the way translation is done nowadays in order to capture the nuance, the details, the idiomatic expressions too, it cannot be kind of one to one or as it was in the past, maybe like token to token, or you have like some set of phrases that are translated and then you look up, oh, this is a phrase that's similar. I'll just translate it like that. And
String to string
yeah,
is what they call it in our industry. So that's a
yeah,
lot of the old translation memory models are built on a string to string
yeah.
basis, so to speak. Go ahead. Sorry, I
Yeah,
interrupted.
yeah, no worries. Yeah, I mean, exactly as you said, that's the case, right? So sometimes these strings can capture meaning within multiple strings. There is sarcasm, there are idioms, different languages work differently. And embeddings help like kind of encoding the data. And when once that data is converted into an embedding and then these embeddings are mapped to a vector space, you can find this more nuanced details around idioms, around kind of meanings spanning across multiple words or multiple structures, multiple sentences. So that's the good thing that these translation mechanisms help understand this added context. And also, what's good is that this can be multilingual. So embeddings are not only in English, there are different models that can help group expressions of different languages kind of close to each other, which means that they have a similar meaning. For example, like Buenos Dias would be close to good day or something of that sort in English. And this works quite well for a lot of languages. But it's not kind of just like maybe this example is quite easy to understand. But for example, let's say in Japanese, there is this difference between for the color blue and green. So there is this word ao and midori, which both kind of refer to the color. So ao refers to the color blue, but it's an old expression that refers to like blue in nature, like sky, sea, and so on. But also people use it for traffic lights, for the color green of the traffic lights. They call it like ow, which would mean blue. So that's very difficult to capture
Yeah.
this kind of subtle difference with just token to token translation or even more advanced translation because it might seem confusing. And this is also present in other languages, like a lot of Slavic languages use the word green for fruit that is not ripe, for example. I think it's the same in Japanese for this word, but like it doesn't mean that the fruit is actually green in color, but it's not yet ripe. So if you don't have embeddings that capture this subtlety here, it's very, very difficult to have this as a correct translation, for example.
Yeah, in my native language in Dutch, for a stoplight, the middle color is orange. And in
Yeah,
English, it's yellow. It's the
yeah,
same light, but we're just calling it something completely different. So that's a great example, which leads me. I
yeah.
was thinking, what are the limitations of traditional token based translation models that embeddings help overcome?
Yeah, yeah. So yeah, exactly. Like as I mentioned, and in this example with the fruit and the traffic lights in Japanese, if you just have the tokens, it's impossible to figure
Yeah,
out what the meaning is there. Or for example, with certain idioms like, for example, in English, letting the cat out of the bag, it
yeah.
doesn't necessarily mean literally getting the animal out of a bag. It's totally unrelated to that. So in token to token translation, this idiom would mean letting a cat out of a bag physically. Whereas with embeddings, you would understand just because this phrase would be positioned differently in texts, in different conversations. So all of these embedding models learn through like vast amounts of data. So just because they know, okay, this expression is not used in the context of like normal cat or normal bag or in sentences where this has the literal meaning, but it is used in somewhat different structures. So that's why the models would then kind of encode in the embeddings. They would represent this aspect of the text and then place this closer to something like a surprise or this was quite unusual and so on. So in terms of similarity, so that's how in these embeddings you then kind of retrieve the data, you get the translations, you search through this vector space. And if you see, oh, this phrase has been placed closer to these other phrases around surprise, unexpectedness, you get the nuance of the meaning quicker and more accurately than if you were going token by token and had no information on the kind of idiomatic nature of that.
It's fascinating. Thank you for sharing that. The concept that you touched upon that kind of made a light bulb go off in my head is that you shouldn't really, I think, and correct me if I'm wrong, you shouldn't really be thinking about these vector embeddings as standalone entities. They're really a way of teaching the AI about the content that you're dealing with, right? So embeddings as a semantic backbone for LangOps. Let's talk about that a little bit. What's the potential you think of embeddings in managing localization, things like glossaries and style guides
Yeah,
and domain-specific language, so to speak?
yeah, yeah, exactly. I mean, like with LangOps, the idea is kind of to have like a universal or like a orchestrated process that is like on top of your other operations so that you can say, okay, now I can kind of streamline this um, multilingual process and so on, or like translations and different documents retrieval and so on. And I think embeddings here will have a big role because they can both help with like the scale of things. So even if you have lots of documents, lots of data, lots of translations, you would be able to kind of use an embedding based approach to kind of have this structure in place, but also in terms of representing the data, embeddings help. And as you said before, it's about the relationships between embeddings. That's what makes the embeddings really good when you scale this operation and you have, let's say, multiple languages, multiple documents, and so on. And then you have one big vector space where you can represent your data in multiple languages. You're able to understand kind of across the barriers of the language what these documents mean, how to translate them, how to position them in this big vector space so that then the retrieval is quicker, so that you don't have to implement specific search in German, specific search in Arabic, in Spanish. You can have everything done in one space and then just place your query or look up whatever you want and get that retrieved, and you can look it up in any language you want. So it's also agnostic, language agnostic on the other side of kind of the user intent way, let's say.
Yeah.
Yeah.
Um, how do you think embeddings and knowledge graphs can complement each other in AI
Yeah.
applications?
Yeah, there's a lot of I guess use of both of these concepts in the tech world. And one way, for example, is to kind of use the embeddings and understanding this nuances and details around intent and within language, or like when retrieving through vast amounts of data, to capture intent, to capture context, to capture the initial, let's say, direction of the query, for example, what the user might want. But then eventually, depending on your systems and the company, you might want like a very specific answer to a question. You might have like some standardized operating procedures for certain machines or industries. So you might want to, after kind of passing through all of these layers of embeddings and retrieval and gathering the intent, you might want to go through your database and find the specific answer, or like track the specific serial number of machine that kind of is related to that user query or question. So in this way, kind of embeddings and knowledge graphs can work together in a way that embeddings help knowledge graphs do their part of the job better in a way, and have like an easier way of going through the data and just concentrate on the specific lookups that are needed. And also what's in a more like technical sense, this when I said when this retrieval happens, you have kind of like a query vector or like what the user wants, and then you search through this space of embeddings that represent different things. The way that this search is done, there are different algorithms and so on. And there is one popular one that's kind of graph based. So it helps this approximate nearest neighbor search between the embeddings to kind of calculate the similarity. It's kind of aided by graphs. So this is called hierarchical navigable small world graphs algorithm. So there is also kind of a technical side of things where these two concepts can work together in many use cases. Yeah.
Yeah. What are some of the practical use cases where embeddings have already made a
Yeah.
difference at SuperLinked?
Yeah. Yeah, there are a lot. There are a lot like at SuperLinked. So we work with a lot of different types of businesses, but we've seen a lot of impact on e-commerce, on hospitality. So with recommendation systems, so for clothing items, for like different travel arrangements, hotels, and so on. So anything where there's like a buyer and a seller relationship where you want to kind of go through different recommendations that are also live. So another key aspect is real time and live recommendation. So
Mm.
the good thing about embedding, besides capturing this nuance, is that they're very quick when new data is introduced. So with all of this older methods, there is this problem that arises often that's called like out of vocabulary problem. Basically, if the model hasn't seen a specific thing in the data or doesn't have a reference to it, it's usually, well, I don't know, that's it. With embeddings, even if you introduce something that's totally new or unseen by the model, you're able to map it out compared to the already existing embeddings. So even if, for example, you search for a product like a t-shirt with stripes and a specific type of a color, and that doesn't exist in the database, you will be able to recommend items that are similar to this that do exist. So this is done very quickly. So for example, if you're a new user going onto the website and you interact with it in different ways, we can very quickly give you personalized recommendations just because we can kind of put this vector into that big vector space and find what's similar and relevant to you. And this is like milliseconds time. So it's almost sometimes unnoticeable that this is happening behind the scenes. It's like real time. So that's a big use case we've had. And also, as I mentioned previously, with with search. So what kind of a lot of businesses have a problem with embeddings is they feel like they cannot integrate all their data because some of the data is like in traditional SQL databases, some is in some other type of files, some is
There's a lot of
images.
there's a
Yeah,
lot of unstructured data as well.
exactly.
That's something we're thinking hard about in the
Yeah,
localization space because especially if you're making, say, a chat bot or something like that, you might want to give that bot access to the German files and way of dealing with customers, so to speak. But that data up until now could never be used because it was unstructured. Uh,
exactly. Yeah. So
there's
yeah, we've also recognized this problem at Superlinked, and we're able to kind of mm, map out things, whether they're images, whether they come from all different sources of data. So kind of help combining structured and unstructured data and generate this complex embeddings that have, let's say, all the relevant context for the business. So that's definitely a problem, probably beyond LangOps.
Yeah, but I'm wondering whether this would be a way to solve some of the issues that I have and make me think of the problematic of being a multilingual speaker. I speak four languages, and at times I'm doing searches where I want to be reaching, say, news in Belgium, but I'm bringing up only American sites because I'm doing a search from Texas, or the other way around. I'm visiting my parents in Switzerland. I want to be searching in Texas, but the only answers it's coming up with are things in Switzerland. Do you think there's opportunities to further tailor responses to customer needs and to be a lot more granular on people's specifics, so to speak?
Yeah, for sure. I think that's like a good example that you mentioned of combining different types of data and then adding them to an embedding and kind of giving out the relevant results. And for example, in this case, for what you've searched, maybe it was like, oh, actually, we want to prioritize the location, or maybe they didn't have embedding search at all. So what we kind of do, or like an advantage with embeddings, is that you can kind of tailor what you want to prioritize. So in this embedding that captures data around location, around intent, around pricing, and so on, you can say, okay, now I want to be more concentrated around pricing because I'm pushing certain discounts and so on. So I want to prioritize that. In another time, it might be, okay, now I want to push this new collection and so on. So I will prioritize that. So you can basically pick in a business sense, you can pick what you want to prioritize and still have the benefits of embedding based search. So it's very powerful.
Yeah, I'm particularly interested in the opportunities that this represents for personalization. Because if I could prompt my way in a search through this particular issue and tell the engine, hey, I'm looking for news in Belgium or in France for this particular thing, and I only want to see results that are coming from that geolocation. It'd be really
Mhm.
helpful if I could just prompt my way through it and explain it, so to speak. I've also noticed that when I'm dealing with AI engines, I'm quickly adapting to that model where I actually can query in a much more sophisticated way, like I would be almost having a conversation with a helper, so to speak, and the person is taking all the input as different layers of what it is that I'm really looking for.
Yeah, exactly. And like, especially, I mean, for me at least, like when I'm searching things like that, I want to also be able to say in the query, like, give me the recent stuff or just like the past 2 weeks. I don't want to fiddle with the filters again and try
Exactly.
to set
Yeah.
things and then,
Yeah.
oh, it's the wrong date. And then
Yeah.
I want to say to negate like different topics or locations. I want to say, give me the recent news. I don't want news about sports this time. I just want about this thing. So exactly, that's kind of what a lot of what we're trying to do is make this natural language search more accessible and kind of integrated with whatever service or website users get to.
Yeah, it's very interesting. I think that search is going to morph into something completely different than the old search where we just punched in a keywords will be in 5 years, nobody will hardly remember how we did that back in the day. It will look really, really archaic.
Yeah.
And from what I gather from you, we'll be having conversations in our searches in which there will be replies in a chat GPT kind of way. Is that correct, you think?
Yeah, that's definitely one direction of how things are shaping up. And definitely the bar, as I've said, is higher now. Keyword search just won't cut it basically for a lot of client expectation. The bar is higher, so I think it's very important to kind of make that transition. And we believe that embeddings are a way to go about this.
Very, very interesting. What metrics should teams track to measure the success of their
Mm.
embedding based
Yeah,
experiments or approaches?
Yeah, this is a big topic, so this could be even a separate talk in itself, especially like in the academic
Yes,
circles and
I'm
so on.
having having a very very interesting geek out experience here, Philip. So if you're fishing to come back, we can arrange for that. I promise. I'm sure we'll find a topic.
Yeah,
Sorry for
yeah.
interrupting. Go ahead.
No, no, that works. Yeah, I'm having fun too. So yeah, basically this is a very big topic in academia too. So kind of how you evaluate this retrieval system. So one of the, I guess, key activities related to embeddings is once you map out and create all of these embeddings, you want to measure when you get these recommendations or you retrieve some embeddings from this big vector space, how good is that? Like whether that fits your needs, what you're trying to get to. So what we've seen at SuperLinked is that a lot of these metrics are only text-based. So they won't include different types of structured data. They won't include images. They won't include different data modalities like prices, recency. So we saw this gap where kind of there is no good public benchmark around this. So actually, in a bit, in some time, we'll release kind of a benchmark related to this to showcase to the world that this is one way of looking at this performance of retrieval and like embedding based search. So that's something coming up in the future, in the near future. But also from a less like going away from the academic rigor, I would say that businesses could just keep their business metrics and evaluations and just see what embeddings can do. With a lot of use cases and clients, we've just told them, okay, you do incremental revenue, fine, evaluate the outcome based on that. Or you do, I don't know how many add to cart orders were bought or abandoned, or all of this more traditional business related metrics. Keep those and see how embeddings work, how embeddings impact these core things in your business, these core business metrics. And that's like the more, I guess, business side of things where you can see the more tangible outcome. Because I guess for people in business, it's not that important, like what the retrieval score is, because you want to see how it works in your own workflow with your own type of data, with your own setup. You don't care about like the academic benchmark if your workflow does not reflect the same thing. So it's to answer the question finally, it's a lot of things, but I think it's working with benchmarks that are public, that include this multimodal type of data, and also benchmarks that or evaluations that businesses have that are meaningful to their business. And what also works with embeddings really well is that you can roll out slowly, think slowly, so you don't have to substitute all your systems and that's it. You can say, okay, for this type of queries, I will try this embedding based recommendations, or for this carousel on my website, only the first one. The other ones, I'll leave them as they are and track how things are there. Do some A/B testing, check clicks, click-through ratio, all of this, whatever metrics the business might want, and then slowly roll out and substitute the existing systems, or just keep the embedding somewhere, the more traditional systems elsewhere. So I don't think like in terms of adoption is something that's scary in a way. It doesn't need like some fundamental shift in the way businesses operate. So that's a good thing in my opinion in like adopting this transition towards more AI native, vector native approach.
Yeah, we're almost at the end of our
Hmm.
conversation, but I want to throw you a final curveball to
Yeah.
put a bow around it, so to speak, and maybe find out something very, very special from you. What do you think is the most exciting thing that you're working on at SuperLinked, or something that we're going to be most amazed about in the evolution of AI in the next couple of years?
Yeah. So, well, the air world is moving very quickly, and
Yeah.
it might be difficult sometimes to keep track of everything, or it might seem that everything is changing all at once, but also nothing is changing just because there's so many things you don't know what to pay attention to. But I'm very excited about this vector native way of thinking and kind of integrating this nuance of language, this way we as humans communicate,
Mm.
but expanding that through different data types, to different modalities, to different sources, and being able to kind of integrate this with already existing architecture, systems, workflows. So what I'm excited about Superlink wise is this kind of paradigm that we have of mixture of encoders. So where basically we generate the embeddings based on the data type that you have.
Mm.
So it's not like a one solution fits all. It's basically the way the embeddings are generated, it adapts to your data. So
Mm.
that even more showcases this kind of nuance and representation of data within the embeddings. And I'm really excited of the impact of that across like industry agnostic, almost language agnostic. So yeah, it's a very, very cool thing.
We're going to be keeping a close eye on SuperLinked and Filip Makraduli to see where personalization and customization takes us in the near future. And I loved having you on, Filip. Thank you so much for sharing all your
It was my
insights.
pleasure.
And I'm going to be keeping an eye on SuperLinked and you as well. And I promise you, in the not too near future, we'll be grabbing you by the collar again and asking you some more questions if you'll allow us to. Thank you so very
Of
much
course.
for being with us this
Thank
morning.
you. Thank you for inviting me. And yeah, of course, I'm happy to talk and exciting times are ahead.
All right. Thank you.
Thank you.